Hello, this presentation is on inverse trigonometric functions. So, what do we know about inverse functions? For instance, if we have a function that takes a 1 as an input and produces 2 as the output, and let's call this function f. What the inverse function does is the inverse function, it takes 2 as the input. So it takes 2 as the input and produces 1 as the output. This is the inverse function. Pretty much what it does, it reverses what the original function does. So if 1 is the input, 2 is the output, then the inverse takes 2 as the input and produces 1 as the output. So 2 as an input produces 1 as the output. So if we look back at the quadratic functions, and the inverses. Let's look at the function here on this figure. As you see the blue curve. Now the inverse of this curve in blue, it would be the curve in red. But if we talk about inverse functions, what we notice is the red curve, which represents the inverse, does not pass the vertical line test. So if it fails the vertical line test, then the inverse is not a function. It's just a relation. Now, can we determine that through the original function, which is the one represented by the blue curve? Well, yes, we can. If we ran horizontal line test, you notice that the horizontal line test fails because it intersects the curve at more than one point. So if the horizontal line intersects the original curve at more than one point, then the vertical line will intersect the the inverse at more than one point. And therefore, if the horizontal line test fails, then the vertical line test fails. So without having the knowledge of the inverse curve, we can determine through the original curve if this function has an inverse function or an inverse relation. Since in this section we're going to be looking at the inverse functions, then we only going to study the functions that have inverse functions, or the functions that we put some restrictions on their domain. So within that restricted domain, the original function will have an inverse function. If it's only inverse relation, we're going to ignore that. So how do we, before we move on with this lesson, so how do we fix the problem? How do we fix the problem over here? So the blue curve will have the blue function, or the blue curve of the original function will actually have an inverse function, not relation. So what we're going to do is this. One of the solutions is to restrict the domain of the original function. So let's call this f. This function, let's call it f. Uh, so let's call this f. Now I'm going to put a restriction on f. So the restriction would be, I want to study this function only from 0 to infinity. 0 to infinity. It means the domain, I'm putting a restriction on the domain which would be the x values. So I'm just going to focus on x values from 0 to infinity, so half the curve. Now, if I sketch the curve, or the inverse curve of the original function f in its restricted domain, which is from 0 to infinity, then it would be only this half over here, only this half. And therefore, now if we ran vertical line test, it will pass vertical line test because there is only one point of intersection. And the horizontal line test over here, it will also pass. So we can copy these curves over here. So this is the f in its restricted domain, and this is f inverse of the function f in its restricted domain. And as you notice here, it's more clear that this passes the horizontal line test and this passes the vertical line test. Therefore, the inverse of the function f in its restricted domain has an inverse function. Um, or let me fix what I just said. The function f in its restricted domain has an inverse function, not a relation. Now, since this lesson is on the trig functions, trigonometric functions, then let's look at these three functions, which are the sine function and tangent function and the cosine function. So if you notice that you notice these curves fail the horizontal line test. So the sine function, it has multiple intersection points with a horizontal line. Same with tangent, multiple intersection points, and as well as the cosine has multiple intersection points. So the solution to this problem is to restrict the domain of each of these functions. And we're going to do this by first looking at the sine function. So we will have the inverse of the sine function, but we have to put a restriction on the domain of the sine function. The domain of the sine function is all real numbers, or negative infinity, comma positive infinity. But once we put the restriction, then it will no longer be all real numbers. So I'm going to go over this. So the inverse of sine function denoted by, so the notation will be sine to the negative 1. And I just want to make sure that do not mistaken this notation for this. So sine to the negative 1 of x is not 1 over sine of x, unless the statement says, well, sine to the negative 1 is a reciprocal. If it says it's a reciprocal, then this will become equality. But this notation, it always refers to the inverse of sine, unless it is stated or otherwise. So do not treat sine inverse for the reciprocal of the sine function, which is 1 over sine. This is not correct. There is another notation, which is arcsine. Arcsine also means sine inverse. So now the inverse sine function, so the inverse sine function is the inverse of a restricted sine function. So it means we have to put a restriction on the domain of the sine function. So the sine function will have an inverse function. So y equals sine, that's the function. And so that is the inverse of the restricted sine function y equals sine. So we read y equals sine inverse of x as y equals the inverse sine at x. This is just so far notation. So those y equals sine inverse is equivalent to sine of y equals x. So what this is saying is if y equals sine inverse of x, so here x is the input, and y is the output. Okay. Now the original function, it will switch the x and the y. So now the y becomes the input. and the x becomes the output. And that's how the inverse function works. So it takes the output and it produces back the input. The original function, what it does, it takes the input, produces the output. The inverse function takes the output, produces back the input. That's why there is a difference between the input and the output of the sine inverse and the original function. Now, here's the graph of the sine function, the blue one. As we see, this is a graph of sine function. So the graph of y equals sine shown above fails what? Obviously, if we run the horizontal line test, it fails the horizontal line test. Any horizontal line test. So if one fails, then we say that okay, the function fails the horizontal line test. So we say the graph of y equals sine shown above fails the uh, horizontal line test. Fails the horizontal line test. Therefore, we must restrict the domain. So the restricted domain will be what? Well, if we study this function from negative pi over 2 to pi over 2, from negative pi over 2 to pi over 2, from negative pi to pi over 2, all the values of the function sine are included, which go from negative 1 to 1. Every single value from negative 1 to 1 will be included. So it is sufficient to study this function from negative pi over 2 to pi over 2. Um, so, restricted domain would be um, bracket negative pi over 2, means we include the negative pi over 2, comma pi over 2 bracket. So we include every single point between negative pi over 2 and pi over 2, and including the endpoints. So this will be the restricted domain. Okay. Now let's work on this exercise. This exercise says sketch the function f of x equals sine of x in its restricted domain, then sketch its inverse sine inverse of x. So let's start with the function sine in its restricted domain. So we said the restricted domain goes from negative pi over 2 to pi over 2. So sine of negative pi over 2 on the unit circle, it will be negative 1. Sine negative pi over 2, it will be negative 1. Oh, sorry, that's a negative 2. Negative 1, which is here. Sine of 0 is 0. Sine of pi over 2 is 1. And then if we take a couple more points, let's say sine negative pi over 4, this would be negative pi over 4. Sine of negative pi over 4, it will be negative root 2 over 2, which is approximately negative 0.7. So the point will be somewhere here. And then if we also take pi over 4, the sine of pi over 4 is 2 over 2, which is approximately 0.7. So 0.7. So I would say the point will be somewhere here. Then we connect this with a curve, smooth curve. And that's the curve of the sine function in its restricted domain. Now, how do we sketch the graph of sine inverse? So what we do, since the x and the y, they switch, the original function x becomes the y of the inverse function, and the y of the original function becomes the x of the inverse function. So that means this point here, the x is negative pi over 2, and the y is negative 1. So let me rewrite it. So negative pi over 2, negative 1. For the inverse, the x becomes a negative 1, the y becomes negative pi over 2. So the x is negative 1, so over here, and the y is negative pi over 2. It's about negative 1.5, let's say around 1.6. So it's going to be somewhere here. It's hard to get the exact point, but we're just going to approximate it. Um, it's somewhere here. It doesn't want to stick. Let me change the color. Maybe it works. No. Okay. Hmm. Okay. Um, maybe it works now. Okay. Okay. That was the problem. All right. And then this point here, 0, 0, stays as 0, 0. And then this point here, pi over 2, 1 becomes 1 pi over 2. So 1 pi over 2. This, okay. This is pi over 2. So 1 pi over 2 is somewhere here. So this one actually was not right. It's -1, which is somewhere here. Negative pi over 2 is somewhere here. So I made a mistake actually. So so the inverse would look like something like that. Something like this. Not exact, but it's a good approximation. This guy. So now looking at the green curve, which is the curve of sine inverse. So sine inverse of x, and the orange, the yellow one is the sine of x. And what is the domain of this green curve? So the domain, we said it goes from -1 to here 1, because the y of the original becomes the x. So it starts from -1 and it goes up to a 1. So the domain will be -1, comma 1. And what is the range? The range, this point here, its y coordinate is -pi over 2. So -pi over 2, because when you switch this point, the -pi over 2 becomes the output. So I can go ahead and write the x and the y. -1 comma -pi over 2. And this point here, it's 1 comma pi over 2. I think this makes it more obvious. 1 comma pi over 2. So the domain goes from -1 to 1, and the range goes from -pi over 2 to pi over 2, comma pi over 2. So let's not make a mistake. This is the domain of the sine inverse, and this is the range of sine inverse, not the origin. So what does this mean? It means whenever we try to find the value of sine inverse, that value has to be in the closed interval -1 comma 1. For instance, if we say, what is sine inverse of 2? Well, that has no value. Why? Because 2 is not in the interval -1, 1. It's outside this interval. So therefore, this has no value. Just want to make sure that when we take the sine inverse of some value, or cosine inverse, or a tangent inverse, we want to make sure that the requirements are met in regards to the domain, the input. The sine and cosine would have a domain -1 to 1. The tangent is negative positive infinity, so that wouldn't be a problem. But sine and cosine, definitely the domain would be -1 to 1. So let's work on the example. Work on example one. Example one says find the exact values of the following inverse check functions. express your answer in both degrees and radians. So what we mean by the exact values, it means we don't want to write, for example, if the answer is pi over 2, so if the answer is pi over 2, we write pi over 2, we don't write 1.57 and so on. This is what he means, like an approximation. We're not going to write an approximation, we write an exact value. Okay. Now, before I go ahead and find those values, let me sketch half of the unit circle. So here's the unit circle. We said that the domain of sine inverse is -1 to 1. The range is -pi over 2 to pi over 2. So if the range is from -pi over 2 to pi over 2, here's -pi over 2, and here is pi over 2. So from -pi over 2 to pi over 2, it will include quadrant 1. That includes quadrant 1 and quadrant, with this, quadrant 1 and quadrant 4. However, as you notice over here, let's put 0 here. So -pi over 2 to pi over 2. So the range is from -pi over 2 to pi over 2. So that means every value from -pi over 2 to 0, that would be negative. I mean, every angle. And every angle from 0 to pi over 2 would be positive. So what are the special angles from 0 to pi over 2? Well, it's pi over 6, pi over 4, and pi over 3. So we got 0, pi over 6, pi over 4, pi over 3, and pi over 2. What are the coordinates of these points? Well, um, this one here, let's put 0 angle over here. Yes. So this point over here, the x is 1, the y is 0. And this point here, the pi over 6, the x is root 3. Root 3 over 2 comma 1 half. This one here, root 2 over 2 comma root 2 over 2. And this one here, the pi over 3, is 1 half, I don't like that, 1 half root 3 over 2. And at pi over 2 is actually, at pi over 2 is 0 comma 1. 0 comma 1. And at -pi over 2 is 0 comma -1. So we got all the positive angles so far. How about negative angles? So this would be negative pi over 6, negative pi over 4, negative pi over 3. This is clockwise direction. So negative pi over 6, negative pi over 4, negative pi over 3. And this is negative pi over 2. So what are the coordinates of these points? Of course, this would be root 3 over 2, negative 1 half. You can look at the unit circle for this. Root 2 over 2, comma, negative root 2 over 2. And this would be 1 half, comma, negative root 3 over 2. So all the x values are the same, and the y values are actually negative in here. Now, can we find example A, which is sine inverse of root 2 over 2? So sine inverse, we said what it does. It takes the output, produces back the input. So if I were to say, what is sine of pi over 6? What is sine pi over 6? So you say it's 1 half. Okay, so sine, let me make sure, sine pi over 6, you say it's 1 half. If I say, what is sine inverse of 1 half? You say pi over 6, because it just reverses. Okay? So here's the idea. Sine inverse of root 2 over 2. Here's root 2 over 2. The sign, you look at the y coordinate, by the way. So sine inverse of root 2 over 2, well, it's pi over 4. So the answer here would be pi over 4. So you produce back the angle. And then example B, sine, arcsine, which is sine inverse of negative 1. Well, what is negative 1? Find negative 1. Here is negative 1. So sine inverse of negative 1, what is it? Negative pi over 2. The angle is negative pi over 2. So if you pretty much have these values set on the unit circle, quadrant 1 and 4, then no problem. Then you can just uh, find the angle that corresponds to that value. What is arcsine of root 3 over 2? So let's find root 3 over 2. So root 3 over 2. So here's root 3 over 2. Sine inverse of root 3 over 2 is pi over 3. So pi over 3. Pi over 3. And then sine inverse of negative 1 half. Well, let's look at the circle. Which one is negative 1 half? Here's negative 1 half. So sine inverse of negative 1 half is negative pi over 6. So this one would be negative pi over 6. And then what's we said, I'm sorry, we said we want an answer in radians and degrees. So let's put the degrees. Pi over 4 is equivalent to 45 degrees. Negative pi over 2 is equivalent to negative 90 degrees. Pi over 3 is equivalent to 60 degrees. And the negative pi over 6 is equivalent to negative 30 degrees. And then the last one, which is kind of tricky, says what is sine inverse of negative 2 pi? So there's a problem with this. Negative 2 pi is approximately negative 6.28. And what did we say about the domain of sine inverse? So the domain sine inverse of x domain is negative 1 to 1. So is negative 6.28 in the interval negative 1 to 1? No. So because it's not, then this has no angle that corresponds to sine inverse of negative 2 pi. So we want to make sure that that input is in between negative 1 and 1. Now, anything that is greater than 1 or smaller than negative 1, then it wouldn't work for the sine inverse. So the next function will be the cosine function, or the inverse of cosine function. So the inverse of cosine function. Again, the notation for inverse cosine function would be the cosine to power of negative 1. And that means the cosine inverse of x. Now, same principle applies to cosine as sine. Y equals cosine inverse of x. That implies that cosine of y equals x. So that means if the inverse cosine takes x as an input and produces y as the output, then so let's use a different color for this one. So it produces y as the output, then the original function cosine takes the y as the input and produces x as the output. So it's the other way around. In other words, if, for example, if we have, let's say, cosine of pi over 3, well, that's 1 half. This implies that cosine inverse of 1 half, so you have to take the output as the input, is pi over 3. This is what it means. So if cosine of pi over 3 equals, if cosine pi over 3 equals 1 half, then cosine 1 half equals pi over 3. I mean, cosine inverse of 1 half equals pi over 3. So it means the here's the output becomes the input, and the input becomes the output. Now, the graph of cosine um, also fails the horizontal line test, and to um, to resolve this issue, the solution to this issue is to put a restriction on the domain. So this time the restriction on the domain, it will be from 0 to pi, because from 0 to pi we would include all the function values in between -1 and 1. We include all those values. So we go from 0 to pi. If we go from -pi/2 to pi/2, like the sine, that doesn't work because it will fail the horizontal line test. So we have to go from 0 to pi. So the cosine function restricted domain is from 0 to pi. So the graph of y equals cosine shown above fails the, again, uh, fails the horizontal line test. So fails the horizontal horizontal line test. Okay. Okay. So the horizontal, my handwriting is horrible. Let's disable this, cancel, disable this. Okay. Okay. So uh, horizontal line best. Therefore, we must restrict the domain. The restricted domain is, we said it's 0 comma pi. 0 comma pi. Okay. Now, on this exercise, again, what we're going to do is going to sketch the cosine function in its restricted domain, and then sketch the inverse function cosine inverse of x. So let's start with the cosine on the restricted domain. We said the restricted domain will start from 0 to pi, so cosine of 0 is 1. This would be our first point, 1. Cosine pi over 2 is 0, and cosine of pi is -1. And the we could do a point in between, let's say pi over 4 would be kind of approximately 0.7, but the curve would look like something like that, right? Okay, now let's label these 3 points. This point here is pi comma -1. This point here is pi over 2, pi over 2 comma 0. This point here is 0 comma 1. So 0 comma 1, pi over 2 comma 0, pi comma -1. Now for the inverse, the x and y, they switch. So let's look at this point here. 0 comma 1 becomes 1 comma 0. So 1 is somewhere here, 1 comma 0. So that will be this point, 1 comma 0. And then at the second point, which is pi over 2 comma 0, becomes 0 comma pi over 2. So 0 comma pi over 2, which somewhere here, will be somewhere there. And this point here is pi comma -1 becomes -1 comma pi. So -1 is somewhere here, comma pi, um, comma pi, which is somewhere bigger than, so actually we're going to be outside this scale. So -1 comma pi, so somewhere there approximately, because this is 1 2 3 3.14, somewhere there. So the inverse curve will be this one here. It's not a perfect graph, but that's the approximation to this approximate curve, and that's the inverse. And you notice that my graphing is not that bad, because it kind of, you could see that there is a reflection over the line y equals x between the orange curve and the red curve. Okay. Now what is the domain of cosine inverse? So the domain of cosine inverse goes from this point to this point, which is again -1 to 1. This is -1 to 1. And what is the range? The range goes from 0 to pi. 0 to pi. So the domain is -1 comma 1, and the range goes from 0 to pi. That means whenever we take the cosine inverse of some value between -1 and 1, the output, which is the angle, it will be some angle from 0 to pi, which is quadrant 1 or quadrant 2. From 0 to pi, it's quadrant 1 and quadrant 2. So the answer should be either on quadrant 1 or quadrant 2, and the input value should be between -1 and 1. So let's see if we, let's work on example 2. Example 2 says find the exact values of the following inverse trig functions. Express your answer in both degrees of radians. So let's do something similar we did with the sine inverse. So let's focus on quadrant 1 and 2, the unit circle, maybe a bit bigger. Okay, quadrant 1 and 2, this will be 0, this is pi over 6, this is pi over 4, pi over 3, pi over 2, 3 pi, no, 2 pi over 3, 2 pi over 3, 3 pi over 4, 5 pi over 6, and pi. So we're going from 0 to pi. So all these angles are included. And then the values, this point here is 1 comma 0. This point here is root 3 over 2 comma 1 half. This one is root 2 over 2 comma root 2 over 2. This point here is 1 half comma root 3 over 2. This one is 0 comma 1. This one is -1 half comma root 3 over 2. This one is negative root 2 over 2 comma root 2 over 2. And this one is negative root 3 over 2 comma 1 half. And this one is -1 comma 0 comma 0. Okay, so we got all the angles, all the values. So it means all the answers for cosine inverse should be one of these angles: 0, pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4, 5 pi over 6, and pi. Of course, we're talking about the special angles, because you could take cosine inverse of some value whose angle between 0 and pi over 6, for example, could be 20 degrees, 25 degrees. But we're going to focus on the special angles, all the special angles, okay? So let's start with the first one, which says what is the arc cosine, which means cosine inverse of negative root 3 over 2. So we need to find where negative root 3 over 2 is. So negative root 3 over 2, cosine is the x. You have to look at the x this time. Negative root 3 over 2 is over here. What's the angle that corresponds to negative root 3 over 2? 5 pi over 6. So the answer is 5 pi over 6. Yeah. So let's erase this. 5 pi over 6, first one. How about negative root 2 over 2? It's over here. Corresponds to 3 pi over 4. It means cosine inverse of negative root 2 over 2 is 3 pi over 4. So this would be 3 pi over 4. This one. Okay, good. Let's look at the next one. Arc inverse of 2.5. I'm sorry. Arc cosine of 2.5, which means cosine inverse of 2.5. Now, 2.5, is it in the domain of the cosine inverse? No, it's not, because the domain of cosine inverse is -1 to 1. 2.5 is bigger than 1. That's outside. Therefore, it's outside the range, or outside the domain. So therefore, this one is this one has no answer. Okay, doesn't exist. Cosine inverse of negative one half. All right, where is negative one half? Here, negative one half. Cosine inverse of negative one half is 2 pi over 3. So this will be 2 pi over 3. Cosine inverse of 0, well, that should be pi over 2 over here. So cosine inverse of 0, that corresponds to pi over 2. So this will be um, pi over 2. And with this, we conclude the portion on cosine inverse. Let's move on to the inverse of the tangent function. Okay, I'm going to go faster on this one. So inverse, the notation will be the same, which is tangent to the power of negative 1 of x. And again, if y equals tangent inverse of x, it means tangent of y equals x, and so on. Same idea as the sine and cosine. Now, does this fail the horizontal line test? Yes, obviously. Do we need to restrict the domain? Certainly. So we're going to restrict the domain um, from negative pi over 2 to pi over 2. And that will include this curve. And one curve actually is sufficient because this curve here is the same as this one, is the same as this one, the same as this one. So the only, and it's the same as this one. So it is sufficient just if we use one curve because it includes all the possible y values or all the values of the function um, tangent. So the restriction will be going from negative pi over 2 to pi over 2, but we have to be careful. At negative pi over 2, there is a vertical asymptote. At pi over 2, there is a vertical asymptote. Therefore, when we write the restricted domain, we should not include negative pi over 2 and pi over 2 because these two values are not in the domain of tangent. So the graph of y equals tangent shown above fails again the horizontal line test. Therefore, we must restrict the domain. The restricted domain is negative pi over 2. As you see, I'm using parenthesis 2 pi over 2. Not like sine or cosine, we used, no, for the sine, sorry, not the cosine. For the sine, we used bracket because sine is defined at pi over 2 and negative pi over 2, but the tangent is not. That's why I'm using parentheses instead of brackets. Okay. Same exercise. We need to sketch the graph of tangent in its restricted domain, and then sketch its inverse, tangent inverse. So this is going to be a bit messy. Let me start with the tangent. Tangent of x in its restricted domain. We said we go from negative pi over 2. Use darker color. So we go from negative pi over 2 to pi over 2. But we understand that at pi over 2 and negative pi over 2, we have a vertical asymptote. So vertical asymptote at pi over 2, negative pi over 2. Vertical asymptote at pi over 2, that's the first thing. And then we know that tangent of 0 is 0, we got 1 point. Tangent of pi over 4, that's a 1. And then tangent negative pi over 4, that's a negative 1. And then we connect these points with a smooth curve. And that's the graph of tangent on the restricted domain, negative pi over 2, restricted domain, negative pi over 2, 2 pi over 2. Okay, good. Now, how do we get the inverse? We switch the x and the y of every point, and in regards to the vertical asymptotes, they become the horizontal asymptotes. So let's start with the asymptotes. The vertical asymptotes, they are x equals negative pi over 2, x equals pi over 2. They become the horizontal asymptotes, which means y equals negative pi over 2, and y equals pi over 2, and and y equals negative pi over 2, y equals pi over 2. So pi over 2, it's somewhere in between 1 and 2. So let's approximate it over here. So we're going to have somewhere in between 1 and 2. It's like 1.57 or something. So negative pi over 2 is also between negative 1 and negative 2. So this vertical asymptotes became the horizontal asymptotes. Now let's focus on the points. We said the 0, 0, when you switch to 0 and 0, it stays at 0, 0. So that's the same point. This point here is pi over 4 comma 1. It becomes 1 comma pi over 4. 1 comma pi over 4. So 1 is somewhere here, comma pi over 4, um, which is definitely a value. Pi over 4 is 3.14 by 4, so value is smaller than 1. So we cannot just put a point there. And then with this is negative pi over 4 comma 0. No, yes, no, sorry. Negative pi over 4 comma negative 1, this point here, it becomes negative 1 comma negative pi over 4. So approximately negative 1, it will be somewhere here. Negative pi over 4 maybe somewhere here. So I'm use different color. I said it's going to be kind of messy, but eventually we're going to get the graph. So it will be this. And then it continues to infinity, approaches the horizontal. Because if you look at the original graph, the yellow one, it goes to infinity, negative infinity. So the blue one will also go to infinity and negative infinity, because it's the inverse. And as you see, you can tell that these two curves, the blue and or the purple and the yellow, they kind of symmetric over the line y equals x. All right. What is the domain of the inverse? Well, it looks like it goes from negative infinity to positive infinity. And what is the range? The range will be from um, negative pi over 2 to pi over 2, because from the horizontal asymptote on the bottom to the horizontal asymptote on the top, because the curve approaches the horizontal asymptotes. So the domain would be negative infinity comma infinity. The range is um, negative pi over 2 comma pi over 2, and of course parenthesis, because the curve will never touch the horizontal asymptote, so we will just approach the horizontal asymptote. We'll approach the negative pi over 2 asymptote and a pi over 2 asymptote. So that's why the range actually uh, excludes negative pi over 2 and pi over 2. Okay, we're going to work on this exercise. Same question. Find the exact values of tangent inverse. Express the values in both degrees of radius. So we're going to be using quadrant 1 and quadrant 4, same as sine, with the exclusion of negative pi over 2 to pi over 2. So um, here's the unit circle. We're going to focus only on quadrant 1 and quadrant 4. We said we take in consideration the zero angle. Okay. So zero angle, pi over 6, pi over 4, pi over 3, and then you got negative pi over 6, negative pi over 4, negative pi over 3. And then we write negative pi over 2 and pi over 2. However, the tangent is undefined at these two places, so let's put open circle, and we'll see what happens. Now, tangent of 0 is 0. I'm just going to write the value of the tangent. Tangent of 0 is 0. Tangent of pi over 6, well, if you look at the unit circle, the tangent is y over x. The y coordinate of at pi over 6 is 1/2. the x coordinate is root 3 over 2. So if you divide 1/2 by root 3 over 2 and you rationalize, if you do the work, it's going to be root 3 over 3. Tangent pi over 4. Tangent pi over 4, it will be y over x again. The y coordinate is root 2 over 2. The x coordinate is root 2 over 2 at pi over 4. So root 2 over 2 divided by root 2 over 2 is 1. I'm just going to put this value. You can verify by going back to the unit circle, divide y by x, and then simplify, rationalize if necessary, and then you end up with those values. The third one, the x coordinate is 1/2, the y coordinate is root 3 over 2. If you divide root 3 over 2 by 1/2, you're going to end up with root 3. Now, all I have to do for the quadrant 4, since the angles are negative here, well, I'm sorry, it has nothing to do with the fact that the angles are negative. On quadrant 4, the tangent is negative. So it means this will be negative root 3 over 3. You can do the work for this one if you wish, or you just conclude it from the points we found in quadrant 1. The tangent is negative on quadrant 4, so therefore if at pi over 6 is the value of tangent is root 3 over 3, at negative pi over 6 it will be negative root 3 over 3. At pi over 4 the tangent is 1, at negative pi over 4 is negative 1. At pi over 3 the value of tangent is root 3, at negative pi over 3 the value of tangent is negative root 3. You can do the work if you wish, or you can just conclude it as I did. So negative root 3. Doing the work meaning you divide the y by x of the coordinates at this point. Okay, now we can go ahead and find the first one, which is arctangent, which is tangent inverse of negative root 3 over 3. So let's find where negative root 3 over 3 is. This is negative root 3 over 3, corresponding angle negative pi over 6. So we write negative pi over 6. Negative 1, where is negative 1? Negative 1 is over here, corresponding angle negative pi over 4. So we got negative pi over 4. Negative pi over 4. Next one, tangent inverse of 0. Here is 0. Tangent inverse of 0 is 0. The angle is 0. So write 0. Example D, arctangent of root 3. Arctangent of root 3. Where is root 3? Root 3 is there, corresponding angle pi over 3. I keep forgetting to write the equivalent angle measured in degrees. I forgot to do that for cosine. You may want to go back and do that. So negative pi over 6, which is negative 30 degrees. Negative pi over 4 is negative 45 degrees. 0 is 0 degrees. Pi over 3 is 60 degrees. And tangent inverse of 1, let's go back here. Where is the 1? It's over here. Tangent inverse of 1 is pi over 4. So this would be pi over 4, irradiance, degrees 45. And with this, we have learned how to find the values of tangent inverse or the angles of the tangent inverse. Composition of trigonometric functions, what it means, if we take the composite of two trig functions, what would the answer be? So you may go ahead and read this on your own. What I'm going to do instead, I'm just going to explain how it works using the examples. Easier to do it through the examples. Okay, example 4 says find the exact value of the following trigonometric expressions, then confirm your answer using calculator. You may do that on your own using a calculator. I'm just going to work on it just algebraically. So this is a composition of two functions. What are the two functions? Tangent inverse of negative 1 over 4, and the other one is tangent. So we're taking the tangent of tangent inverse of negative 1 over 4. So what is tangent inverse of negative 1 over 4? Well, we can do the work for it because negative 1 over 4 is not one of those special angles. So if I draw a triangle over here, The reason why I draw it on quadrant 4, because tangent inverse of negative value, that's on quadrant 4. Remember the restricted domain of tangent function. In order for the tangent function to have an inverse tangent, you need to restrict the domain. The restricted domain was from negative pi over 2 to pi over 2. Therefore, it's quadrant 1 and quadrant 4. Quadrant 1 and quadrant 4. So because we're taking the tangent of the tangent inverse of negative 1 over 4, negative 1 over 4 is negative value, so it must be quadrant 4. So here's theta. What I can do here, I can use a trick. I'm going to say, okay, if tangent inverse of negative 1 over 4 equals some angle theta, because I know the tangent inverse of some value, some number, it would be an angle. I'm going to call it theta. What this means that tangent theta is negative 1 over 4. This is what it means. It means tangent theta is negative 1 over 4. So what is tangent? Tangent is the opposite over the adjacent. So the opposite must be negative 1. The adjacent must be 4. Can't be otherwise. Because the adjacent is on the positive x-axis, so it must be positive. The opposite is is actually below the x-axis. It's on the negative y-axis, so it must be the negative correspond to the opposite. So negative 1 will be the opposite. Now here this will answer itself actually. So let's write this. What is tangent inverse of negative 1 over 4? Tangent inverse of negative 1 over 4. What is this? What is tangent inverse of negative 1 over 4? Well, according to me, take a look over here. Tangent inverse of negative 1 over 4 is theta. So I'm going to say, well, this is going to be replaced with theta. And then what is tangent? It's like we're just turning around. We're turning around the same point. What is tangent of theta? Well, from this triangle, tangent of theta is opposite of adjacent, which is negative 1 over 4. Negative 1. So negative 1 over 4. So the answer is negative 1 over 4 for this. You may not need to use the diagram and all this work. Well, you can reason with it. Tangent inverse of negative 1 over 4 must be some angle theta. So tangent theta must be negative 1 over 4. So now for the tangent inverse domain is negative to positive infinity. It means you don't have to worry about the input, not like sine and cosine. For sine inverse and cosine inverse, any input must be in between negative 1 and 1, including negative 1 and 1. Anything not in the interval, not on the interval negative 1 to 1, does not work for the sine or cosine, the sine inverse, cosine inverse. Tangent inverse, actually, its domain is negative to positive infinity. Therefore, any value here works, so we don't have to worry about that. Let's do the second one. Second one, we have the sine inverse of sine of 2 pi over 3. What is sine of 2 pi over 3? Sine of 2 pi over 3, if you look at the unit circle, that would be root 3 over 2. Root 3 over 2. Okay. What is sine inverse of root 3 over 2? Now, if you go back, sine inverse of root 3 over 2. We go back here. Sine inverse of root 3 over 2. Sine inverse of root 3 over 2. See, sine inverse, the sine function uses the y coordinate. Here's root 3 over 2, somewhere over there. So sine inverse of root 3 over 2, what is it? Pi over 3. This is the angle that corresponds to root 3 over 2. So pi over 3 is the answer. So this would be pi over 3. Okay, let's do the next one. This is cosine inverse. What's cosine of 3 pi over 4? Look at the unit circle. Cosine of 3 pi over 4 is negative root 2 over 2. Cosine of 3 pi over 4 is on the second quadrant. and the answer is negative root 2 over 2. What is cosine inverse of negative root 2 over 2? It's 3 pi over 4. Look at the quadrant 2 of the cosine and look at the x, which x corresponds to 3 pi over 4. It's the negative root 2 over 2x that corresponds actually to 3 pi over 4. Let's work on this one. Sine inverse. What is sine 7 pi over 4? Sine 7 pi over 4 should be negative root 2 over 2. Take a look at the unit circle. Okay. Now, what is sine inverse of negative root 2 over 2? Well, it's not 7 pi over 4. It's going to be negative pi over 4. Why? Because if you look back at the quadrant 1 and 4 we used for sine inverse, if we try to find sine inverse of a negative value, must be in quadrant 4, but you just when you find the angles, you have to rotate clockwise. It's not going to be 7 pi over 4. It's going to be negative pi over 4. You may go back to the sine inverse and you look at the quadrant 1 and 4 that I draw above. Okay, so I'm going to continue. So cosine. Now, what is cosine? Oh, what is cosine inverse of negative root 2 over 2? Well, cosine inverse of negative root 2 over 2, cosine inverse we use quadrant 1 and 2. Cosine is positive from quadrant 1, negative from quadrant 2. Because the negative root 2 over 2 is negative, well, therefore we're using quadrant 2. Find the negative root 2 over 2 on quadrant 2 and see which angle corresponds to negative root 2 over 2. Which angle corresponds to that x, because the cosine is the x. So negative root 2 over 2, that must be 3 pi over 4. Okay. And what is cosine of 3 pi over 4? Negative root 2 over 2. So this will be actually the same value. It's just back and forth. This one is a bit different because the cosine of tangent inverse of 5 over 12. So let's reason with it this way. If tangent inverse of 5 over 12 equals some angle, we call it theta. That means tangent theta is 5 over 12. It's positive, so it must be quadrant 1. Here's the triangle. Tangent theta is 5 over 12, 5 over 12. So when we do the math to find the missing side, so this is theta, missing side, which is hypotenuse, it will be, I believe, 13. Yeah, 13. Okay, now we're saying that tangent inverse of 5 over 12 is theta. That means this one here is theta. This is theta. So we put theta here. What is cosine of theta? Well, look at the triangle. Cosine of theta. Cosine is adjacent. Cosine is adjacent, which is 12, over hypotenuse, which is 13. Okay, 12. Oh, no. Okay, let's redo this. So it's 12 over 13. So cosine of theta is 12 over 13. That's the answer. Sine of tangent inverse of 3 over 4, same idea. We start with this. We're going to say, okay, well, let tangent inverse of 3 over 4 equals some angle theta. That means tangent of theta is 3 over 4. And again, it's positive. 3 over 4 is positive. So there must be quadrant 1. Somewhere here. Tangent of theta is 3 over 4. 3 is the opposite. 4 is the adjacent, so this must be 5. I think so. 9 and 16, yeah, 5. Okay, now we're going to say, well, sine, what did we say about tangent inverse of 3 over 4? We say it's theta. What is sine of theta here on the on this triangle? Sine is opposite over hypotenuse, so 3 over 5. So you do it at one step at a time. One step at a time. Let's work on this one. Cotangent of sine inverse of, so cotangent of sine inverse of negative one third. Negative one third is not one of the special angles, so we have to draw a triangle. Because negative one third is a negative number, then the quadrant, it must be the triangle must be on quadrant 4, because sine inverse uses quadrant 1 or 4 if the value is positive, quadrant 1 if the value is negative, if the input, what I mean by the value means the input, if the input is positive, quadrant 1, if the input is negative, quadrant 4. Now we're going to say, okay, well, let's put it over here. So let sine, let's work on it on this side. Let sine inverse of negative 1 over 3 equals theta. That means sine of theta is negative 1 over 3. So sine of theta is negative 1 over 3. Sine is what? Sine is opposite over hypotenuse. So hypotenuse must be the 3 because it's always positive. The opposite must be negative here because it's below the x-axis. It's on the negative y-axis. So good. Now we're dealing with cotangent, so most likely we're going to need to determine the adjacent. What is the adjacent? We have to use Pythagorean theorem. In here is not obvious, so I'm going to use the Pythagorean theorem to find the adjacent. So let's call the adjacent a for now. So a squared plus negative 1 squared equals 3 squared. So a squared equals 3 squared is 9. 9 minus 1 is 8. Because negative 1 squared is 1. Minus 1 minus 1 so is 8. So a equals root 8, which is 2 root 2. Root 8, which is 2 root 2. Okay, good. So this will be 2 root 2. Now, we said sine inverse of negative 1/3. That's theta. So we're going to write theta over here. Sine inverse of negative 1/3 is theta. What is cotangent of theta? Cotangent is adjacent over opposite. Adjacent over opposite. Adjacent, which is 2 root 2. Opposite, which is negative 1. So this simplifies to negative 2 root 2. And that's the value of cotangent of sine inverse of negative 1/3. We've got a few more examples. It's a lot of practice. Maybe this one we don't need. We don't need the. For this example, we don't need the triangle. Why? Because we know what sine inverse of negative 1/2 is. It's only it corresponds, negative 1/2 corresponds to the one of the special angles, only unit circle. So sine inverse of negative 1/2, because this is a negative value, it must be 0.4, so it would be negative pi over 6. So this would be cosine of negative pi over 6. Now, what is cosine of negative pi over 6? Again, look at the unit circle. Is root 3 over 2. Root 3 over 2. In other words, here's the circle. Here's positive pi over 6. Here's negative pi over 6. So at this point here, the coordinates are root 3 over 2, comma, negative 1/2. Since we're doing the cosine of negative pi over 6, cosine of negative pi over 6, the cosine is the x, so it's root 3 over 2. Okay. Tangent of cosine inverse of 4 over 7. 4 over 7 is not one of the special values, so we need the triangle. So this is quadrant 1 because it's 4 over 7 is positive. So let's put theta, and let's say we say let cosine. So let cosine inverse of 4 over 7 equals some angle theta. So that means cosine of theta is 4 over 7. That's what it means. What is cosine? Adjacent over hypotenuse. So that must be 4 and that must be 7. And then we use Pythagorean theorem to find the opposite. Let's call the opposite x, or let's call it y. No, let's call it x. So okay, so we do x squared plus 4 squared, which is 16, equals 7 squared, which is 49. So x squared is 49. 49 minus 16. So 49 minus 16, which is 33. And then x equals root 33. And that cannot be simplified. Also, we ignore the negative 33 because x is above the x-axis, which is on the positive y-axis. So this is root 33. Okay, now we said that according to the assumption we made here, we said that cosine inverse of 4 over 7, cosine inverse of 4 over 7 is theta. So it means I'm just going to put theta over here. What is tangent theta? Look at the triangle. Look at the triangle. What is tangent theta? Tangent is what? Tangent is opposite over adjacent. Root 33 over 4. That's the answer. Last one. Last example. Same idea. Tangent inverse of 3 over 8. So, okay. So we're going to say, well, let tangent inverse of 3 over 8 equals some angle theta. That means tangent of theta is 3 over 8. Tangent is the opposite over adjacent, 3 over 8. And then we use Pythagorean theorem to find the missing side. And that should be 9 plus 64, which is 73. So this would be root 73. You can do the math. So root 73. And this is angle theta. Okay. Now, let's finish this. Now here's the idea. We said that tangent inverse of 3 over 8 is theta. So it means sine of theta. Because tangent inverse of 3 over 8 is theta. Look at the triangle. What is sine of theta? Opposite of hypotenuse. 3 over square root of 73. Rationalize 3 square root of 73 over 73. And with this, we have come to the end of the presentation. Thank you for watching.